Hi folks, today we're going to be going through a Tektronix 2245A 100 megahertz oscilloscope. I bought it from eBay and the seller honestly described what issues it had. So we're going to fire this thing up, take a look at it and see what the story here is. Okay, so I've got the camera moved and we're going to fire this thing up and see what we get here. Okay, it wants us, I don't know if you can see this well, but it looks like there's a lot of crap going through this text here. So they're saying put this two divisions below the middle, like that. Okay, I don't know what one is. Okay, it's going through a self-cal for the time base now. I boarded the self-cal for the vertical section. Okay, it says there's probable battery failure. This text is not filling the screen. These should be down in the corners. Let's see. And I am not able to find my traces here. What's up? Here we go. Okay, this is looking like we have some power supply issues. We've got noise in the trace. The seller said when you move the scale illumination, it moves things up and down. So I'm pretty confident we're going to have power supply problems. So I'm going to shut this down. We're going to take the cover off and measure the power supplies and see what we have. Okay, so I've got the scope out of the case and we're going to check all the low voltage power supplies. Now if you look at this section of the schematic right here, they show this connector that has all the different low voltage DC points. However, if you look at the connector numbers, you'll see that they're not in sequence. So what I did is I just took a piece of paper and I wrote them down in the order in which we're going to find them in the connector. So I'm just going to go down and we're going to check these out and see how close they are. So we start with connector 1 and 2 should be 5 volts. We have 5.14 and 5.14. Pin 3, no connection. Pin 4 is ground. Pin 5 is -5. Pin 6 is -15. Pin 7 is +15. Pin 8 is 7.5. Pin 9 is -7.5. Pin 10 is 58. Pin 11 is 130. Pin 12 is ground. Okay, so they don't seem too far out. None of these are regulated supplies, so you're going to see a little variation. But the other thing I'm going to want to take a look at now is to see what kind of ripple we might have on this. So I'm going to shut this down. I'm going to turn my scope on because the one tool you really need when you're troubleshooting a scope is a scope. Okay, so I've got the oscilloscope turned on and we're going to start probing the same points we probed with the DMM. We're looking for ripple. Now, when you're dealing with test equipment and oscilloscopes like this, ripple is far, far tighter than you would find in, say, a stereo. So we're just going to probe these supplies and see if any of them don't look good. I've got the scope set for 100 millivolts per division. And we're going to start with the positive 5 volt. That's good. And this is the negative 5 volt, also looks good. Negative 15 does not look good. Looks like we've got 100 millivolts of ripple on there. Positive 15 looks good. The positive 7.5 looks good. The negative 7.5 looks good. 58 volt doesn't look so hot. And 130. Now the 58 and 130 may be within spec. I'm going to have to pull it up and we'll take a look at that. Okay, so if you look at this chart I printed out, it shows the power supply voltages or ripple limits. And you can see that for the most part these are very low. And I believe we're going to find our problem having looked at the schematic on our positive 7.5 volt line, because that's only supposed to be between 4 and 8 millivolts, and I'm getting closer to 50. All these that say that they have such low limits are suspect, and for the usual reasons, we probably have some bad capacitors in the power supply. Okay, so I've taken all the screws out from this board and removed this connector. So now we can flip this board up this way and I can take this shield out, and down here is our power supply. And we're going to start changing out all these capacitors, and if you notice, here's our battery, so we're going to have to get one of those and replace it. Okay, made some progress on this scope. I got in all the capacitors I needed to rebuild the power supply. I was a little concerned, and this may be a problem, but the capacitors I took out all look like this. Let me show you one of them. They are 3-pin. We have the capacitor pins, and then we have this pin that runs along the outside. These appear to be shielded, and I'm not sure where to source these, so I just put regular capacitors in there, and it may be causing us a little bit of problem. But the other thing I had was I removed the lithium battery because we were getting a battery failure error, and this battery tests good. So what I did is, there's a gentleman that goes by the handle, the Emperor of Test Equipment. He's got a page online. It's really entertaining, and all he does is he buys broken test equipment, fixes it, throws it on a shelf in his basement. He just enjoys fixing things, and in that way I kind of feel like a kindred spirit, but this guy is crazy good. So what he does is, instead of soldering a battery to the board, he takes an external battery holder like this and mounts it on the back, and there's a lot of good reasons for this. First and foremost, a lot of this older equipment, when you get it, the batteries have leaked. And leaking batteries that are soldered to circuit boards can cause all manner of damage. So that's good reason number one. Good reason number two is you don't have to disassemble the test equipment to change the batteries every few years when they die. All you do is pop it off the back, put a couple new ones in, you're good to go. However, when I did this, I still kept getting the battery error. So I'm going to turn it on now, and I'll show you what I did that cleared the battery error. And by the way, this unit still has troubles, and we'll talk about that. But as I said, we're making headway. So we have a good trace. Flickering's all gone. We have good signal. Our text, however, is still too small and not located in the right quadrants of the screen, and the scale illumination still makes everything move. What I discovered was these supplies, which I said were unregulated, are actually pre-regulated in the switch mode power supply, and I believe we have a problem there. Now, the problem I had with the battery error that I managed to clear was here. Now, this is the battery, and it feeds through the 620 ohm resistor into this diode and powers up the RAM IC. When the scope's on, it's powered through this diode here, and this diode back biases so it doesn't go into the battery. These batteries are lithium, don't like to be charged. However, what I discovered was, with this battery pack, I had good voltage here and here, but not at the anode of this diode. And even though you think they'd be right next to one another, they're on opposite sides of the board. Now, in test equipment like this, you'll find there are multi-layer circuit boards. So you can't really see the traces. It may be sandwiched in the center of the board. And I'll show you what I had to do that made this work. And that is, I had to run a jumper from that 620 ohm resistor all the way over to the diode, which is on the other side of the board. Once I did that, our battery error is cleared. So that's where I'm going to leave this off right now. I'm going to have to make a part 2 of this video when I determine what's wrong with the pre-regulators, and there may still be a separate problem with the readout. More as it develops. Thank you for watching, and as always, I'd like to give back to the community that has given me so much. Take care.